All right, here we go. Unit 5, Lesson 1, the quadratic formula. Now, this unit is called complex numbers. We're going to learn more about those in the next few days. But first, we need to backtrack to motivate their use. And we're going to backtrack all the way to working with quadratic functions. So, quadratic functions, remember, those are functions that are in this form something, so some number times x squared plus some other number times x plus a number, and maybe those could be minuses, right? But those are quadratic functions. And what we're going to do is we're going to remind ourselves how we can work with quadratic functions, starting with a reminder of all of the tools we learned that we could use to sketch one by hand. So let's say we had this function x squared plus 2x minus 8. Now, by memory, right, I just kind of remember two things. I remember A, that this is a parabola shape. And I remember B, that because the leading term, the x squared, is a positive x squared, this thing's going to open up. So it's going to look something like that. But other than that, right, who knows? There's like a bunch of different ways that this function could look, and we need to actually do a little bit more work to figure out what it looks like. Now, we've done this before. I'm going to pull way back. The trick to graphing this by hand, this is my favorite way to graph these by hand, is to use the concept of zeros. So if this is the y-axis, y is equal to 0 anywhere along the x-axis, right? Because y isn't 1, it's not -1. And so what I want to find is I want to find when my function x squared plus 2x minus 8 is equal to 0. So what I'm going to do is I'm going to set it equal to 0. So we could have 0 is equal to x squared minus 2x, or sorry, I think it was plus 2x and minus 8. So we have plus 2x and minus 8. And now we've learned that, yeah, if you stared here long enough, you might come up with the two answers. Sometimes not, though. And the best way to do this, to figure this out, is by factoring. Because I can't just look at that and figure out what values of x could I plug in to make that a true statement. But if I can figure out how to factor it, right? If I can figure out how to break this thing up into its two factors that would multiply to make it. So we're going to have an x and an x. We need two numbers here that multiply to make -8, but add to make 2. Okay, that's going to be plus 4 and minus 2. What I can see from that more easily is that there's two possibilities here that would make this statement true. Either x equals -4 or x equals 2. Because if either one of those things were true, I don't even care what's happening in the other parenthesis, because as soon as one of them is 0, the whole thing is 0. And because we didn't really change it, if this is a true statement, so is this. So I've found that if x is -4 or x is equal to 2, y is equal to 0, right? So these are the 2 points here. We call these the zeros. We call them the zeros because they are the x values that make y equal to 0. I'll write this on the outside so it doesn't get in the way. -4, 0. Now, the trick to graphing this, right, is to just create a quick table of values centered around 1, 2, 1, 2, centered around the middle, right? These things are symmetric. So if I take the zeros and I draw a line straight down in between them, I know my vertex of my function is going to fall on that line, right? So if I were to just make a guess, right, maybe it looks something, I missed it by a little bit. Oh, God, terrible drawing. But you get the idea. I want to see, and this is why we need values here to plug in, I want to see where does the center, the vertex of this function lie. And so we'll go through this part pretty quickly here. In fact, like I'm just going to enter this in as a function. I've got my Desmos pulled up over here, and I'm just going to quickly like go through what this table of values would look like here. If you plug in -1, you work out the math. Again, I'll do the first one by hand here. So if you plug in -1, and if you find f of -1, you'd have -1 squared plus 2 times -1 minus 8. You'd have 1 minus 2 minus 8. You'd have -9. So we know here that our vertex is at -1, -9. And you'd go on from here. You would like just do some more values in the table. Okay, what happens at 0 when x is 0, y is -8? What happens at 1 when x is 1, y is -5? When x is 2, we already know y is 0. We already found that one. Let's see if we can do one more. When x is 3, y is 7. So we could plot those. 0, -8, 1, -5, 2, 0, 3, 7. And because it's symmetrical, I could probably I can just say, okay, I could go through and I could do these. I know this is going to be symmetrical here. So if I keep going this way, if I plug in -2, I'll get out a -8. If I plug in a -3, I'll get it at -5. If I plug out a -4, I'll get out a 0. We already know. So you can just kind of like create a symmetrical shape here, making sure that you do this all. Ooh, and I missed that one. I see that now because that's supposed to be 3, 7. So that was a little bit off. But you get the idea that we could graph this function like this. And so now we have a pretty good idea of what that looks like. But what we're going to find out today is that there are obviously functions where those zeros don't fall neatly on whole numbers. Or just if you don't like factoring, right? If you found the factoring hard, there are other ways that we can find those zeros. And this is where we're going to use, depending on your Algebra 1 class, you may have seen this before, you may have not. We're going to use the quadratic formula. So it's a big one, right? And we're going to talk about it. The scope of this class, proving where it comes from, unfortunately, if we have time at the end, we'll come back to it. There's a much better proof that uses calculus, so that's something to look forward to in a couple of years. But the like Algebra 2 proof takes a long time, and it's just not high on the priority list right now. But here is in general what it says. If you have a quadratic equation, so ax squared plus bx plus c, in that form, and it is set equal to 0, so like you're trying to find, right? Like you're trying to find the zeros. You're trying to find that -4 and that 2. There is a formula that whole number, decimal, wherever those are, this formula will find them. And it says these zeros, right? This is a 0. That's not the number 0, but it's like x comma 0. It's what value of x would make this function 0 by this formula. -b, this means here plus or minus. So I'll actually write that out there. Plus or minus the square root of b squared minus 4ac all over 2a. Sometimes you'll see that plus minus written like that. So that means, right, there's going to be two solutions like you can see on this graph. We've got -4 and 2, right? There are cases where if the square root part was 0, right, if this all worked out to be 0, that would be where you'd only have one solution. We'll do a little bit more of that tomorrow. And then we're going to build into this whole unit what happens when you have no zeros. Okay. But so here's just a quick example. We'll do 2 examples here today of this, and then you're going to have some work to do on delta math. Let's say I hate factoring, right? If you can factor it, oh, I forgot to change this one over. So let's change this one over. Let's change this over to x squared minus 2x plus 8, or plus 2x minus 8. So because we already know the answers here. We know the answers are -4 and 2. I'm going to do one example here where we already know the answers. Okay, so the first thing that's really important, you have to, right? These a, b, and c's in the formula refer to the coefficients, not the variables. So they refer to just the numbers in the place of a, b, and c. So in this case, there is an understood 1 in front of the x squared. There is a 2 in front of the x, that is the b term, and there is a -8 for the c term. And so again, if we have f of x equals x squared plus 2x minus 8, and I want to know when does 0 equal x squared plus 2x minus 8, I can apply the quadratic formula. What it says is these zeros, x, are equal to -b, so -2, plus or minus the square root of b squared, 2 squared, minus 4 times a is 1, times c is -8, all over 2 times a. That's a lot going on there. But let's just kind of work it out step by step. So this would be equal to -2 plus or minus if we kind of, let's go do this somewhere else to save space. So if we have 2 squared minus 4 times, okay, 1, that's just 1 times negative 8. We're going to have 4 plus 32. That's going to be equal to 36. So we have negative 2 plus or minus the square root of 36 all over 2. And so we're going to have negative 2 plus or minus 6 all over 2. And at this point, you can break it up into the plus version and the minus version. Negative 2 plus 6 over 2. That's going to be 4 over 2. There's your solution of 2 right there. Negative 2 minus 6 over 2. Negative 8 over 2 equals negative 4. So there's your negative 4 solution. Now in this case, that's obviously not the best way to do this problem. That is so much more work than factoring. So let me show you an example of where it would be really helpful. So let's take a look. We're going to do a couple more examples here. The quadratic formula is not something you have to memorize. This will always be given to you. If you have a place where you do your math work, I recommend write it down, put it on a sticky note, have it ready to reference. The quadratic formula can be a big help in these situations. So because we're pushing 11 minutes in the video, I'm going to skip this example because it's not that much different than the one that we just did. And I want to do just this one example here. Find the solutions to 2x squared plus 2x. So that this graph here, this is y equals 2x squared plus 2x equals 12. And so like usual, all right, I'm already telling you the answers here. The answers here are 2 and negative 3. Because when x is 2, both of these are 12. And when x is negative 3, both of these are 12. But here's how you could solve this using the quadratic formula. Quadratic formula says we need this in the form ax squared plus bx plus c. Now this can be pluses or minuses, but we need it equal to 0. So step 1 would be to subtract 12 from both sides. That would give us 2x squared plus 2x minus 12 is equal to 0. Now, this could also be factored. But I want you to, we're going to have examples. I think today they're all going to be, you could solve it with factoring, but tomorrow, next class, we'll do some with decimals. Step 2 is to identify your A, B, and C. A is 2, B is also 2, and C is equal to negative 12. Step 3 is to fill into the quadratic formula. I'll write it here one more time. Negative b plus or minus the square root of b squared minus 4ac all over 2a. When you're old like me, you'll either be a math teacher and have that memorized, or you won't be and you won't have it memorized anymore. But you can always look it up. If we take this and we write in the a, b, and c, negative b is 2, plus or minus the square root of b squared, so 2 squared minus 4. I like to put a parenthesis around that to remind myself if it's negative, got to square the negative as well. A is 2, c is negative 12. All of that over 2 times a is 2. So we just keep working this out. Negative 2 plus or minus the square root of, well, this is going to be 4 minus 4 times 2 is 8 times negative 12. This is going to be 4 minus, I tried to do too much in my head. Let's just say 4 times 2 is 8 times negative 12. So we're going to have 4. It's going to be plus, because it's a negative times a negative. All right, 8 times 12. We're going to have 80, 96. Okay, we're going to have 4 plus 96. We're going to have 100. All of the ones you do today will have a perfect square in the radical. If you don't have a perfect square, so everything here is going to be like 1, 4, 9, 16, 25. They're all going to be perfect squares today. No longer after that, though. Divided by 4, we're going to have negative 2 plus or minus 10 over 4. And so one possibility is negative 2 plus 10 over 4. That's going to be 8 over 4 equals 2. There is your one solution. Or negative 2 minus 10 over 4. That's going to be negative 12 over 4. There is your negative 3. The last thing I just want to note, I use all this graphical context so you can place it, so you can see what's actually going on here, right? But if I just blind gave you, if I literally just gave you this with no graphical context, and that's what the delta maths are going to look like today, if you can rewrite this in standard quadratic form, set equal to 0, you can use the quadratic formula to solve any quadratic equation. It could solve 3x squared minus 17x equals 42. It doesn't matter. If you set that equal to 0, 3x squared minus 17x minus 42 is equal to 0. If you use the quadratic formula with a is 3, b is negative 17, and c is negative 42, it'll work. So it's a perfect example of a trade-off in math where there are often tricks that if you have real understanding of like factoring and zeros, you can go much faster. But quadratic formula, reliable, it's harder, it's more work, but it will always work. So good luck on the delta math. Let me know if you have any questions.